Welcome to the DIY Honda Garage channel. The DTC P0502 indicates an issue in the continuously variable transmission (CVT) speed sensor circuit, specifically pertaining to an open or short in the electrical circuit. This code occurs when there is no electrical signal being received by the transmission control module (TCM) from the CVT speed sensor. Unlike mechanical issues, this code strictly points to electrical faults that disrupt the functionality of the speed sensor, which plays a critical role in informing the TCM of the vehicle's speed. The TCM uses this information to regulate engine performance and transmission shifting, ensuring a smooth driving experience. The sensor is typically located near the CVT assembly, making it accessible for diagnostic checks and repairs. Hence, understanding and addressing this DTC requires a methodical approach to troubleshoot electrical connections rather than mechanical components. The error description of DTC P0502 points to a malfunction within the electrical circuit associated with the CVT speed sensor. The continuously variable transmission speed sensor is paramount for transmitting vehicle speed data to the TCM. If this sensor does not operate correctly due to a circuit problem, it can lead to transmission performance issues. The sensor is usually situated on the transmission itself, close to the CVT assembly. Its position allows it to gauge the rotational speed accurately, which is critical for proper vehicle operation. Without accurate speed readings, the TCM may miscalculate the shifting needs of the transmission, leading to a suboptimal driving experience, including potential lurching or stalling. Several potential causes can lead to the appearance of the DTC P0502. Firstly, an electrical circuit failure may exist, indicating issues within the wiring or connections between the CVT speed sensor and the TCM. An open circuit occurs when the electrical path is incomplete, preventing signals from reaching the TCM. Conversely, a shorted wiring condition may cause unintended connections, disrupting normal operation. Additionally, a faulty CVT speed sensor can directly lead to this DTC, although this is often less common. Each of these possibilities requires thorough investigation, focusing primarily on electrical checks due to the specific nature of this DTC. When DTC P0502 is triggered, drivers may experience a variety of symptoms during vehicle operation. Commonly reported issues include erratic transmission behavior, which can manifest as unanticipated shifts or hesitation during acceleration. Additionally, engine performance may suffer due to incorrect data being sent to the TCM, resulting in a less responsive throttle or stalling conditions. Often, drivers will notice a warning light on the dashboard, indicating that the vehicle's onboard diagnostics have detected an issue needing attention. It's important to understand that these symptoms can negatively impact both the drivability and safety of the vehicle, necessitating prompt diagnostics and repairs. The first step in troubleshooting DTC P0502 emphasizes the necessity of verifying the problem. Begin by turning the ignition to the on position without starting the engine. Next, clear the DTC using the Honda Diagnostic System, HDS, which is crucial for resetting any existing faults that may have been stored. After clearing the code, securely raise the vehicle on a lift to ensure safe access. It's essential that all four wheels can rotate freely during the testing process to simulate actual driving conditions. With the vehicle elevated, enter the Vehicle Stability Assist (VSA) maintenance mode and operate the vehicle by shifting into D and maintaining an engine speed of at least 1,000 RPM. After about 4 seconds, release the accelerator and allow the vehicle to return to a stop. Finally, check for any pending or confirmed DTCs using the HDS to ascertain if P0502 reappeared. In the second troubleshooting step, the focus shifts to diagnosing the electrical supply to the CVT speed sensor. After ensuring the vehicle is in the off-lock mode, disconnect the 3P connector of the CVT speed sensor to investigate the VCC3 line. Once disconnected, turn the ignition to the on mode and prepare to measure voltage between two test points. The first test point will be the female terminal number 3 of the CVT speed sensor connector, and the second will be the body ground. It is imperative to ensure the vehicle is in the on mode for accurate readings. If the measured voltage is approximately 5 volts, this indicates that the VCC3 wire is functioning correctly, allowing for further testing. Should the voltage read differently, this points towards issues in the line that require further inspection and repairs. The third step involves conducting an open wire check on the VCC3 line to ensure continuity. Start by switching the vehicle off, lock, and disconnecting the TCM50P connector. With both connectors detached, continuity must be assessed between two specific test points. The first point is terminal number 3 of the CVT speed sensor connector, while the second point is terminal number 41 from the TCM connector. Checking continuity is crucial to determine whether the VCC3 wire has any breaks along its length. If continuity is successful, the VCC3 wire is deemed functional, and inspection should then turn to the TCM, possibly referencing authorized service information for further diagnostics. If the continuity test fails, repairs to the open in the VCC3 line will be necessary to restore proper circuit integrity. Step 4 entails another voltage check, this time focusing on the SG3 line of the CVT speed sensor circuit. The vehicle should remain in the on mode with the CVT speed sensor 3P connector still disconnected. Measure the voltage between 2 points designated as female terminals number 2 and number 3 of the CVT speed sensor connector. If the voltage measurement shows around 5 volts, it suggests that the SG3 wire is functioning correctly, indicating proper signal pathways to the TCM. If the voltage is not present, however, it points to an open in the SG3 wire that would need addressing. Subsequent repairs should include restoring the connection to ensure that data flows uninterrupted between the speed sensor and TCM, crucial for reliable vehicle operation. The fifth troubleshooting step checks for shorted wiring within the VEL PWM line. Begin by ensuring the vehicle is in the off-lock mode and disconnect the TCM50P connector. Similar to previous steps, continuity is tested, but this time between test points at the CVT speed sensor connector number 1 and a body ground. If continuity is established, it points to a short circuit that needs repair for the VEL PWM line. This line operates by controlling pulse width modulation signals, vital for the operation of the CVT. Any short to ground would disrupt these signals. If continuity does not indicate a short condition, then the VEL PWM wire is regarded as not shorted, and one should progress to further checks elsewhere in the system. In the final troubleshooting step, the focus is again on the VEL PWM line, but this time assessing whether an open condition exists. Ensure that the vehicle is off lock mode before carrying out the continuity check between the VEL PWM line, specifically pin number 1 of the CVT speed sensor connector and pin number 22 from the TCM connector. A successful continuity check will indicate that the VEL PWM wire is functioning correctly, in which case the next logical step is to replace the CVT speed sensor itself, as it may likely be the root cause of the DTC. If continuity fails the test, repairs will need to be made to the VEL PWM line to restore proper function and communication between the sensor and TCM. After completing the necessary repairs, it's imperative to verify that the issue has been resolved. Reconnect all components and clear any existing DTCs using the HDS tool. Perform a test drive to ensure that the vehicle operates without interruption and that the warning light does not reappear. During the test drive, the goal is to replicate driving conditions to see if the TCM now receives accurate signals from the CVT speed sensor without reporting errors. If the DTC does not return and the transmission operates smoothly, this indicates a successful repair. It's essential to document all findings and repairs made during this process for future reference and diagnostics. To prevent occurrences of DTC P0502 in the future, it is advisable to implement a rigorous preventive maintenance schedule focusing on electrical components. Regular inspections of the wiring harness connecting the CVT speed sensor to the TCM can help identify any signs of wear or damage before they lead to operational failures. Likewise, ensuring that all connectors are clean and securely fastened is crucial for maintaining optimal performance. Regular checks of electrical signals to and from the components can catch issues early and prevent the need for more extensive repairs. Establishing a structured maintenance routine will significantly enhance vehicle reliability and safeguard against unanticipated downtime due to similar DTCs arising. In conclusion, DTC P0502 indicates a critical electrical issue related to the CVT speed sensor circuit that requires immediate attention. Understanding the implications of this error is key to ensuring both safety and performance in Honda Accord models from 2017 to 2023. The outlined, structured troubleshooting steps provide a clear pathway to diagnosing and rectifying the problem effectively. Following these steps meticulously, while keeping an emphasis on preventive maintenance practices, will enhance vehicle reliability moving forward. By addressing electrical issues proactively, owners and technicians can ensure a smoother driving experience without the disruptions that accompany DTC codes. Please like and subscribe to the channel. See you next time.